Hey gang, let's make fetch happen. So you tell me, what do you want to know about fetch, APIs, client server, HTTP communication, and the like?
I think just general practice. This is like fetching from APIs, right? Yeah, just
No other
practicing.
fetch. What else?
Like query strings and stuff would be good.
What else?
In terms of best practice, not just in the JavaScript, but also on the Rails side would be great.
What else?
A quick little ditty on how to hide a key or client or personal information on the back end when we push to GitHub.
So that's going to be a mod 3 topic.
Okay.
Because to do that, that means your server actually has to make the request, not your client. And so what you end up doing is your client makes a request to the server, which has the key on it. And then the server makes the request to the API for you with the key, gets the thing back, and then sends it back to you. And so the key only goes here to here, not over to the client.
Right.
So we can talk about some tricks for doing that in mod 3.
So you don't need
Really
to
understand. Oh, sorry. Go ahead,
back
Alex.
end. Oh, it's okay. You need to put during the hackathon. Yeah, we needed to put the key somewhere in the back end, I believe.
Yep.
I didn't really know what that was about. So we are going to learn that next. That shouldn't be something I should be learning in this.
Yeah, I wouldn't like. You have enough on your plate for mod 2. I don't think we've ever had a mod 2 student who could do that successfully. So you don't need to be the first.
When you say key, are you talking about like key value pairs or what is this?
API key.
So yeah, let's say this API is like, oh yeah, totally you can use our API if you have a key. Most of the time they're free. Some of the time they're not. But it's how they know that you requested the data, not some rando.
Is it like an SSH key kind of, or?
Very similar idea.
Okay.
Authentication key.
Yeah. But the challenge is if it runs on a browser, everybody can see it. There's no way to hide something in the browser. If it's running on your computer, you can take a look at it. It's not possible to keep anything secret there. So if we have something that needs to be secret, that means it can't be in the browser. But this whole client server thing, it's fucking turtles all the way down, man. So who is a client and who is a server is purely a matter of perspective. So client requests something from a server serves it back to them. Okay, well, this can also do that. And at that point, now that's a client and this is a server. And then that one can also ask for something. And now that's a client and this is a server. This pattern can go on indefinitely. And it's like a pretty fundamental part of not just the web, how like a lot of software works, clients and servers. And so if you need to keep something secret, the thing that's acting as the client just needs to be somewhere that the user can't control it. Proxying, that's called also. Other questions about fetch that we should talk about or practice or something? All right, here's a place to start. So what I'd like everybody to do is we're going to try to get a Pokemon of your choice to show up on a web page. That can be, and if you don't know what a Pokemon is, just go with Pikachu. How about? So
I was literally about to do a build and burn with the Poke API too.
oh, bless you. Now you can do it with us and maybe get some feedback.
2 birds.
All right, so there is the URL. You have an example URL right here. If you swap out Ditto for Pikachu or anyone that you want, you're going to get back this object when you fetch that. And if you go down to sprites, you get all these cool URLs that you could put on an image or something. Or if that's feeling like a bit much for you, then the name, just get the name to show up on the page. But from scratch, I want you to take a few minutes, see if you can get either the name or the name and the sprite to show up on a web page. Go! Oh, I've been talking on mute. Yeah, there we go. So fist to 5. Fist is, I don't know what we were supposed to be doing. 5 is, I got something showing up on a page. How far did you get? Throw it up. Good, good. Cool, cool, cool. Thank you, Javarie. Mr. Glasgow, how'd you do? Gotcha. Cool. So let's take a look at the code. So your HTML page should have looked something kind of like this. Some easy things to miss. We got to have some containers to put this stuff in when we get it back. Don't just tack it onto the end of the body. That is sloppy. Grown-ups, you got this. Other thing that's easy to miss is not deferring your script loading, because this runs top to bottom without that. If I do this, it goes this line, this line, this line, this line, this line. And so in this script, when I go, hey, throw this onto an H1, it goes, the fuck is an H1? All I know about is this. So we put defer in there, and that makes it wait until the entire page is done loading. Questions about the HTML? Oops. I don't know if I can even do that. So that's a greater than character entity for greater than GT. So you notice how my syntax highlighting breaks on this? I wonder if it actually loaded the page. No, it did it. So let's say that it didn't, because it probably shouldn't have. I'm using that less than sign there. Uh-oh, that's exactly what I would have done if I were closing the tag. The way around that is a thing called character entities. They all start with ampersand, they all end with semicolon, and then they have little codes in between them. So that one, for example, is less than. And when you run it, still shows up right. Other questions about HTML? Cool. Let's take a look at the JS. So I grab references to that H1. I grab a reference to that image. I fetch. I parse the response. I take that response, throw it in the text content for the image tag, throw that in the source for the image, throw that in the alt for the image. Because images are supposed to have alt tags. Questions about the gerbil script for this? Anything not clear on this?
Can I see your image tag in your HTML again? Okay. Thank you.
They're just containers for us to drop stuff in. Some things that are easy to screw up on this. Leaving out the parsing the response. Got to do it. Not invoking that JSON method. And again, can't underscore this enough. You are not turning something into JSON. You are not turning something into JSON. You are not turning something into JSON. You are turning JSON into JavaScript objects. That's what that line of code does. You get back JSON from the server. You need to reconstitute it back into a JavaScript object. That ends up showing up right there. This response and this response are not the same thing. They happen to be named the same thing, but they don't have to be. This could be result. That's fine. Does the exact same thing. Doesn't have to be anything specific. We can call it whatever we want. We call it Pikachu. All those things do the same thing.
Cal, on line 9, could we also set the title attribute there as well? Or would we have to have image.title and then Pikachu name?
You could also put a title on it. They do different things though.
Right. But you
Like-
can't do that on one line?
No.
Okay.
I'm now trying to think if there's a clever way you could do it on one line.
Since they both have the same value.
All right, now I'm gonna see if I can do it on one line. So if you had an array of those. Holy shit! There you go. Like, there's your one-liner. It's not worth it. Don't do it that way.
Yeah. Fun to see though. What about width and height as an attribute? Can we set it there too?
Yeah, totally.
Okay.
So we could do image.style. That's where all the style attributes are. If there are properties that have multiple words in them, like font weight, then you camel case them like you do in JavaScript instead of kebab casing like you do in CSS.
Okay.
There are actually surprisingly few good reasons to do that. There's our giant Pikachu and our normal weight H1. There are surprisingly few good reasons to do a style in JavaScript. You're better off, if you wanted to do something like that, then do it with classes. So you could say something like img class list add giant. And now when you serve this up, if I element inspect that, it has that class on it, and then use your style sheet to say, oh, and by the way, giant means 100% height, 100% width.
Right.
But like that should be your JavaScript interaction with styles is through classes rather than editing them directly. Most of the time, there's a handful of things you have to use JavaScript for, but you're probably not going to run into them today, probably not tomorrow.
Are they all dynamic?
Yep.
Okay.
It usually has to do with like, I want to set the height of this container to be the same as the height of this thing. Like you have to program that.
So this is all happening on the front end?
Yep.
But is there like a seeding the back end type thing that you do with these? No? Okay.
Because the backend for this is this API. It's provided for us. When you guys, like what you're doing in the code challenge, what you'll do in the projects next week, that's nobody else is providing you the API, so you provide your own. It's the exact same concept though. And let's talk about that seeding thing a little bit more, because this is a thing that like even capstone students, I think, get a little bit confused on sometimes. So I've got a browser, makes an HTTP request to an API. The API interacts with the database. Or the API sends shit back to the browser. So another way to think about this is that the API and the database are both working with data. We'll call this data at rest and data in motion. It's always moving through this system until it hits the database, and then it stops. And the purpose of that is when I kill this API, like when I turn off the server, when I Control-C and Rails S again, everything that was in motion goes away, starts up fresh. This is where stuff's getting actually saved. So we get that stuff out of there. Now let's add another leg to this. This API can also request stuff from another API. And maybe it's also connected to a database and whatever else. But the whole purpose of these APIs is I don't need to know shit about this. I don't need to know whether this is also a Rails backend, or whether they have a database or not, or whether they're keeping it all in memory. Who gives a shit? All I know is that if I ask for this data, I get it back. And that also means I don't need to save it in my database. I can get the data from here. I can get the data from here. Doesn't matter. You could consider it data at rest in either case. So what seeds are for is putting your database in a predictable state every time for testing. That's it. We kind of fudged that a little bit in mod 1, where like a lot of you, like that was your data. You put your books in there and seeds and stuff. Like that's not the actual way that you do that in real life. You never seed your database in production. What you do is you get a job at fucking some startup, Fitbit, whatever. The thing you spend the first week doing is getting your computer set up. It takes a long time because you got to download all the tools and you got to download their enormous code base. And then you got to have all the shit installed that like makes that code base run. And you got to have their database set up and configured and like all this kind of stuff. But like you're not using their production data. That'd be insane. It would violate user privacy. It would be just literally physically too big. It might be hundreds and hundreds of gigs. But like you need to be able to run their application. So what you do is you go, okay, cool. So I got all this stuff installed. And now I'm going to seed my local database on my laptop with a bunch of like representative sample data. So that I'm not trying to run the application with no data. It's like an application with no data isn't an application. So I seed it with some stuff that sort of seems representative. And sometimes like people even get to know the seeds a little bit. Like, oh yeah, that's the user profile for Jared. And Jared is fucked something up on his user profile. And so that ends up making things show up weird on pages sometimes. But like, that's your way that you get to experiment with that kind of stuff. Or it's a social media platform and you seed it with some posts. Well, you need to also be able to delete posts, update posts, all those kinds of things. And then you can rerun your seeds and get the database right back to where it was after you experimented with deleting all the posts. That's what seeds are for, not really keeping data. And so especially when you're interacting with other APIs, like these arrows are the big thing there. I asked something for data and got it. I asked something for data and got it. It doesn't matter that this was a database and this was an API. From my standpoint, they're kind of the same thing. Hopefully that was an illuminating tangent.
So the seeds are used to test functionality type stuff.
Correct.
Okay.
They're not like your actual data. It's like you'll notice the first thing you do in a seed file, blow out whatever's there and then add the new stuff. Well, if that was like your actual app, you just deleted all the shit that I wrote. You deleted my dog pictures. Other questions?
With the Pokemon API I mean, I did this, but I'm not quite sure why. So when in the fetch, the URL,
Mhm.
it wasn't pokeapi.co. It was whatever was in the little, the bar, the search bar, the bar that says API/v2/Pokemon/ whatever Pokemon.
I pull it up. This?
Yeah, so it's not pokeapi.co what you're putting for fetch. It would be whatever that is, right?
No, it's this whole thing. And that is a really easy alley-oop into this next topic, query params and query strings and URLs and stuff. So let's talk about let's break down URLs a little bit. I'm going to mangle it a little bit for purposes of illustration. Okay, so here's a URL. There are 6 parts of this URL. I want you to think to yourself for a second and see how many of those 6 you can pull out. There's actually a 7th one that's not visible here, but it is technically there. 6 that you can see, an extra one that you can't. Cool. Let's see if we can work through these. Cassie, do you have one?
Yeah, the HTTPS:// is the protocol.
Yeah, rock on. So that's the protocol. It's not the only one. SSH is a protocol. FTP is a protocol. Let's see. SMTP, that's how email works. All kinds of different protocols. They usually end in P or the P is usually in there somewhere. All a protocol is like an agreement between the client and the server. We're speaking the same language, right? I'm about to send you an HTTP request. Has a method, has a URL, has headers, has a body. We're good on all that? Cool. All right, so that's the protocol. Gerald, give me another one.
Following that is the domain name.
Cool, so all of this is the domain name. That's something that's uniquely identifying something on the web. It's a shortcut to an IP address. Like, that's literally it. So pokeapi.co, you can even look at what it is. If I look at this, no, not that one. If I look at this first request here, that was the IP address that pokeapi.co resolved to. That's 172. .67.134.239. And true story, if you just put that IP address into the browser, you get to the same place. So if I open up a new tab and just pop that in, oops, it doesn't want me to get, oh, it's because I didn't do it secure. Wonder if what we do if we put the port on? Nope. What if, fuck, didn't want me to do it. Preventing me from accessing it directly. But that's the general gist of it. Google doesn't do that though. It's unusual.
That a security thing or?
Maybe, but I don't know what that would, why that would make anything more secure. So if I try, go into a new tab and I pop that in, it takes me to Google. There's nothing like I said, if it runs in your browser, it's not a secret. It can't be. You can see everything that happens in your browser. It's your computer. Nothing secret on it.
So those numbers just become the domain name.
Exactly.
Easier to remember a domain name. So they just like,
Bingo.
okay.
We need the IP addresses because that's how we locate stuff on the web. It's like your postal address. Exact same kind of idea. In fact, it was modeled after the postal system. But yeah, nobody's going to remember this shit. And so this is the internet. This is the web. This is a little abstraction on top of it. So that when you type in pokeapi.co, it looks up in a phone book what the actual address for that is and takes you there instead.
I think I want to ask for a lesson that just goes all the way down this rabbit hole. Like, how does that then become like something that the internet is able to? I want to understand all that stuff.
Like very few people do. And like, it doesn't have anything to do with application development. It doesn't hurt to know. It is complicated, really complicated, and held together with tin cans and wires. Like the fact
There's on the bottom of the ocean, right? Like,
oh, yep, that's a big part of it. There's a big cable on the bottom of the ocean. It's broken before, spying through it. And even like within the country, USA Internet Backbones. Okay, so these are called internet backbones. It's like fractal. So you have your home network, and then you have a network that goes to your neighborhood, and you have a network that goes to your city, and you have one that goes. And so like the highest level one's called a backbone, and it looks like this. And they go in little loops too, and those loops are owned by different people. And the only reason that they allow traffic between each other is because they all agreed that that was probably a pretty good idea. One time they got in a like some of these loops got in a fight. I think it was specifically this like Illinois-ish loop in here, got pissed at some other loop owner, and so stopped accepting their traffic, and then the internet just broke. It's like, that's about how like secure all this shit is. So just heads up.
awesome.
It's a miracle that any of this works at all.
Are those all giant cables that are underground or something?
Not necessarily. They can go overhead too.
But they are just giant cables somewhere? Okay.
All right, so still talking about parts of a URL. This is the domain name. It's an alias for an IP address. Alex, anything else you were able to pick out of this?
The query params after the question mark.
Yes.
Question mark and after.
Yep. All of this. So strictly speaking, this is a query string, which is made up of query params, which have a key and a value. The entire thing is called a query string. And then each little pair is its own thing. And we can do multiple ones also, separate them with ampersands. So that would be like only new, something like that. All of that would be the query string. Cool. What we use the query string for most of the time is not like, query string has a couple things going for it. One, it's in the URL, which means it's bookmarkable. Stuff you send in like the bodies of requests, not bookmarkable. So if you want to send somebody back to the same page, it needs to be in the URL. You want to get back to the same page or link somebody to something. All that information has to be in the URL somehow. So most of the time we do that with another piece of this puzzle we haven't talked about yet, but query string is really good for modifiers on that. So sort order, that's a pretty good one. Any filtering, stuff that has to do with the presentation of the same data, that's a pretty good place to put that kind of stuff. Jordan, can you find another part of this URL?
Yeah. So we've got the path, the file path.
So the path is this part right here. So when we find the computer at this IP address, this is the data that we end up sending it. It could be literally a file. And so it's going to go into a folder on the computer that it finds at that address and look for, in the API folder, in the V2 folder, for a file called Pika. So it could be that. Or what things like Rails do is they just intercept that and they go, well, why don't you just give me the rest of that path? Don't go looking for a file. I'm going to use this thing called a router, and I'll figure out what I want to do with that request. And so when you do get heroin or whatever, that's /heroin. That would be the path on that. And so you're giving Rails an opportunity to say, hey, when I get a request with this path, I want you to send that request to this action on this controller, and then let that action take it from there. But yeah, originally all that was folders and files. And in fact, that's exactly what's happening on like when you do light server. I saw in tech questions that some people were playing with that over the weekend. So if I have some text file, all right, so I've got some text file there. Fire up light server. Now I can go localhost 3000 / some text file.txt, and hey, there it is. I can make some folder. I can move it into that folder. So now it's in there. And if I run the server again and try to refresh this, 404, can't find it. It's a very thin metaphor. It's literally just going through folders and looking for files most of the time. Cool. Two more things on this. Kevin Johnson, you want to give it a shot? You see anything that we're missing?
Honestly, I thought we had it all.
I know we're close. All right, open it up to anybody. There's three things. Two we can see, one we can't, that we're missing.
We're missing them.
Subdomain?
Subdomain, very nice.
Is that the www?
Yes, it is.
I should have just gone with it. I knew it.
www is a subdomain. Not a lot of people know that. So it could be api.pokeapi.co. It could be, so I'm writing like a little quiz engine thing right now. Think fast. It's a subdomain. I have a domain. That's a subdomain. So use subdomains when it's mostly a branding thing. You have a domain name. That's what people are identifying as your thing. And then you can make multiple websites within that if you want. And then you can route those all to different IP addresses even if you want to. For example, I'll show you. God, why do they make it so fucking hard to get to the management console? There we go. So this is what this looks like on the backside. All right, if you go to the regular website, it should go to either one of those IP addresses. If you go to this one, oops, not that one. If you go to this one, it should go to either one of these IP addresses. This is the phone book.
And AWS is like a hosting place, or?
AWS is everything. AWS fucking runs the entire internet at this point. But it's servers, it's routing, it's storage.
That's Amazon? Or?
Yeah. This is Amazon. The shopping part of Amazon is a frankly pretty small part of the empire at this point. Is
there anything else besides AWS that runs anything else? Like,
yes, Google has a competitor called GCP, Google Cloud Platform, and Microsoft has one called Azure. Like market share wise, holy shit. Cloud services market share. $96 billion.
so like if you're hosting your website on Bluehost or whatever, is it actually on AWS or?
Yes. Heroku. Heroku is AWS under the hood. Like this is the infrastructure of the internet right now. That's growth. That's combined. Enterprise SaaS. There we go. 49% compared to everybody else. It is absolutely dominant. And so things that they have, these are all of the Amazon Web Services. As you can see, there's a lot of them. So some like major ones, EC2 is computer on demand. I would like a computer for an hour. I want to run a server on it or shit. Like I was talking about this in the gaming channel on Never Devs today. You can get an Amazon EC2 instance with a fucking killer graphics card, remote into it. And I was reading last night, they have the latencies down to like 40 milliseconds or so on that. And you could play a AAA game at ultra settings and pay by the hour for it. Actually, you pay by the second for it. I know a couple people that just use it as their full-time work computers. They use a Chromebook and then just use that to SSH into a really good EC2 instance. You honestly can't tell the difference. It's just like having a computer. You can run servers on it. You can do all kinds of cool stuff. Lambda, like this is getting more popular. This is function as a service. So like I was telling John Higger this morning, file uploading as a service. So you write a function that uploads a file, and then you put it on Lambda, and you pay every time that function runs. It's like a fraction of a penny every time that you do that. Way better than running your own server for it. S3 is like a pro version of Google Drive. This is the one that the politicians keep getting popped for because they put shit in S3. Okay, I need you to see how stupid this is. I probably have some public buckets in here. Yeah. Maybe this. Here, maybe. Just can be public. I'm gonna see. I'm trying to find one that I have that's. Oh, those are just redirect ones. Maybe this one. Hey, okay, here it is. This is public. Everybody can see what's in here. And like when you click around, it's just warning signs all over the place going, no, stop doing this. Anyone in the world can see any of this stuff. Now, if it's a website, that's the whole point, is that anybody in the world can see it. But people keep like putting all of their like top secret shit in here and then just opening it all the way up. Clicked past all of these things and we're like, nah, I don't want to figure out the permission system. To their credit though, like the Amazon permission system is Byzantine and fucking very hard to get right. But yeah, every time someone's like, leaked cloud data, this is what they mean.
So it's like their pictures and their documents and whatever is like all in there.
So like in this case, this one is when you go to Web App Kitchen Sink and upload a file. I'm going to upload this desktop link. Cool. So it uploaded it to the cloud. It used that Lambda so I paid a fraction of a penny for that thing I just did. And it uploaded it here. And if I go over here, hey, look, what do you know? There it is.
So what exactly is that?
This is the file that I just uploaded on this
Okay,
site.
so that's a file from your computer.
Correct.
Okay.
And so yeah, it's like a Google Drive that you can program with. There's databases, there's quantum computing. All of this stuff is like Amazon's version of GitHub. They have a text editor. They've got a bunch of IoT shit. Like this is the infrastructure of the web right now.
Will we learn it inevitably as going into the field as devs?
Yeah, like you kind of can't not. Brace yourself though, it sucks. Like Amazon is maybe the worst, AWS is maybe the worst designed thing I've ever seen. It's a technical marvel, but it is awful to work with. We're talking like multiple competing doc sites that disagree with each other. Very like insider lingo. They sell a lot of certifications, not because this stuff needs to be this hard, just because it is this hard. So yeah, buckle up, but there's pretty much no getting away from it. All right, back on track. I'll give you the last couple. This one is TLD, top level domain. These are actually administered by different companies. They're making new ones all the time. Like I remember when .party came out. Cool TLDs. .amex, .android, .bmw. So yeah, like they're just companies that manage these things. And then you buy the you buy a domain from that company. .wiki, tunes, .theater. They're like sometimes they have different restrictions. So like real estate investment trust. All right, well you have to like be one of those to have that site. .org very recently opened up. So you used to have to be a nonprofit to have a .org. You don't anymore as of like last year, but you still need to be a degree granting institution to do a .edu.
How much does it cost to get a top level domain?
Well, you buy the domain. The TLDs have like different prices to them. The weirder ones are usually cheaper.
Or like one that doesn't exist yet. Like, could you start one of your own and then?
So all that stuff is done through an organization called ICANN, the Internet Corporation for Assigning Names and Numbers. Like you'd need to get them to go like, yeah, cool. You can make one. So like Amex, for example, probably paid a shit ton to ICANN for that.
Because if you own, could you own it as an individual, like a top level domain?
Yeah.
Or you could? And then every time anybody used it, they'd have to pay you?
People would have to buy they'd have to buy the domains from you. It's like when you buy something like a .com is owned by VeriSign. It's just a company. I went to a convention once and they had a booth. And when like all the TLDs were sort of taking off, they're like, whoa. Let's not forget like the classics here. Like .com is still like pretty much where it's at. I don't know why everybody's getting so excited about all these other ones, man. They were like working PR pretty hard for like the integrity of .com. But yeah, you don't buy it directly through them. You buy it usually through a broker like name.com or Route 53 is like what the Amazon one is. So if I go over to Route 53, these were all like domains that like I bought on Amazon, but all of them are .coms except the education and the org. All the .coms are like ultimately those Amazon then bought those from VeriSign and then resold it to me. So those are TLDs. And like they set pricing differently on them. Like by and large, .coms are about $15 a year, kind of across the board. With like whenever they come out with a new TLD that they think is going to be hot, like shit, there was one recently that everybody was using for a while. .io. All the .io ones that were like short names, 2 letters, 3 letters, they sold those for a fucking fortune. Like, so they can reserve them and go, oh, you want io.io or x.io or something like that. Cool, that'll be $10,000, please. So that's how that works. And then the one other thing that's missing on this, anybody know what it is? It's sneaky.
Fragments.
Close. Yeah, we didn't talk about fragments, but those would go before the query string.
I thought they went after.
No, they're like tacked onto the end of the path. So they start with pound signs, and it might be like heading. These will take you to, they will scroll the page to something with that ID. That's a fragment. So like if you go to kylecoberly.com and see how that thing got added at the end? That's a fragment. And so if I send that that URL to someone, it takes them to that part of the page. And it's just going off of IDs. It looks for the first thing it can find with an ID of heading and scrolls to that. All right, still one more to go.
Was it the request itself, the HTTP verb?
Nope. Good guess. If you're typing it into a browser, it's always get.
Right.
But this is where we're sending the request to.
Is it a port?
Yes, very nice. So tucked in here is an implied port, actually, 443. If you are sending a request over HTTP, it'll default to port 80. If you're sending it over HTTPS, it'll default to port 443. And so those don't show up in the browser because they're assumed. You only put them in if it's going to be something different. For example, localhost 3000. There's a couple ports you're not allowed. Well, you're always allowed to do it ultimately, but there's a few that your computer will go like, don't do that one. All of the 5000s, I think your computer generally won't let you do. They're not different. It's like a convention thing, where since this is conventionally on 443 and this is conventionally on port 80, then like they are expected to be used in certain ways. When you're connecting to Postgres, Postgres is conventionally at port 5432.
So what are these ports like in the physical world? Are they anything or?
No, it's all magic logic. But you can sort of think of them as different ways to connect to your computer. How many different things can be connected to your computer over a network simultaneously? And so when you run a local host, what's happening here is you're saying, I want my computer to pretend like it's a completely different computer over the internet. And I want to try to connect to it through a browser. It's not actually a different computer. It's all your laptop. But you can trick your computer into thinking it's a different computer by hosting this server over a port and then accessing that through that port. And that's how we do local web development. One last thing I want to show you to give you an idea of what's possible with this. So we've talked about the internet. It's a network of networks. So these are all IP addresses on the public internet. And they can talk to each other, so on. So like I have an IP address So like that's the router for my house is that. And so if I'm 98 dot whatever, then that gets you to my house. Once you're in my house, there's a whole other network there. And these have their own IP addresses and whatnot. So my Raspberry Pis, my laptop, all that stuff.
Do you like Alexas and stuff have those?
Yeah, everything in your house. And so if I go to my router, which is here. These are all the internet connected devices in my house right now. These are the IP addresses they have. Only like you can't get to these. All you can do is send a message to my router within my house. These are all the IP addresses. And so like
smart lights and everything are all, wow.
everything's got an IP address. So check this out. I don't know if it's going to come through over the Zoom super well. I'm going to try. So I am SSHing on my phone into 192.168.0.50, which is my computer. And, ooh, not happy with that. Am I on my Wi-Fi? Well, maybe I'm already in. Try it again.
What about like a smart garage door opener on your, okay.
This is my smart garage door opener right there. All right, my phone's not letting me do it. It's making it look like an asshole in front of my friends. But yeah, since my phone and my computer are on the same network, I can log into one from the other. And I have these things forwarded. I think all of these are down right now, but if you go to my IP address, is it down? It's probably down. So if you like tack on the 443 to the end of that. Yeah, I don't have wired anything right now. I have 80 wired up though. Maybe that's why. Yeah, I think that computer's off. If you go to port 80 in my at my IP address, it's going to go to this computer in my house, and it's going to go to port 80 on that, and it's going to ask for a file called index.html. Pretty fucking cool.
How secure are these things? Like, not that anybody would, but if a hacker wanted to like come turn your lights on and off or something like.
So they would have to get into like through this kind of thing. They would need to go to your public IP address. From that, you would need to have forwarded them to a computer that's on your network. And that computer would have to be trusted by other things on your network. So like, yeah, that could absolutely happen. You would have to make a lot of mistakes first.
Okay. That's interesting.
Now, like, here's an interesting point though. Let's say you were able to get onto some computer on the public internet. By default, most IoT devices are like insecure shit. Like default passwords, no security on any of them. The big joke is that in IoT, the S stands for security. So if you had a bunch of like out of the box stuff that you hadn't set up right, and somebody got onto a computer in your network, then yeah, they could turn off your lights and do whatever else. Or like more likely, like what they would do is turn it into a botnet and use that to attack other people or mine Bitcoin or something like that.
Like somebody could get into a smart car and start driving it.
Yeah.
That doesn't seem good.
Spoiler alert, that was the plot of Silicon Valley.
Oh, it is? That's a show, right?
Correct. Yeah, the last season was about that. Now, again, like you have to leave those things wide open, but you could. That is a mistake that you could make.
How, as developers, can we protect us from ourselves in that way?
Break it yourself. Like the way that I learned about all of this shit was exactly what you just saw, like setting up home networks and like trying to hack myself and just playing with this stuff, see how it works. The most dangerous thing you can do is be afraid of these kinds of things. Like learn them. They're really interesting. They're kind of fun, and they like enable you to do all kinds of badass shit. Like I can log into my laptop from anywhere in the world. Like if my laptop is plugged in at home and I have my phone, I can log into my laptop. I can work. I ran Cypress tests on my phone this Sunday. So like, I don't know, that's how you're going to find out like, oh, fuck. But like, I wouldn't have to have put my password in here. That's how you learn that stuff. Cool. Anything else you guys want to talk about?
Do we have any videos on the Firebase site for advanced Rails, particularly with integrating an API and doing our own logic on the controllers and whatnot?
Like, I think we have more videos on Rails than anything else on Firebase.
Okay, I'll take a look. Thank you.
Anything else?
I just have a question on, I guess, fetching something that's pretty deep in the Pokemon API. I guess it would be fetching like the type of Pokemon it is.
So you're fetching a resource. You fetch the Pokemon, and then from that, it's just JavaScript. It's just accessing properties on that object.
Okay, yeah. I mean, I guess like I'm having like my path, I guess, is having trouble finding it. Just because it's like it's types and then 0 and then like slot and then like type and then like
all that kind of stuff. So
I mean, I have that in there, but it's still, I'm just wondering what.
So to troubleshoot this kind of thing, log it. And then when you pull it up, what you want to do is figure out what did you have to do to get the thing that you want. So I go, all right, well, it's Pokemon.held items at 0.item.name. So and like I called mine Pikachu or whatever. So Pikachu.held items at 0.item.name should give me Oranberry.
Okay, yeah, because I have that for the type, but I can't pull up the type for some reason. It's
right.
giving me like an error with the 0.
All right, let's take a look at it. But for everybody else, thank you very much. All right, go ahead and screen share, Kevin.
Thank you, Kyle.
Thanks, Kyle.
I kind of want to see this if you don't mind.
No, hang out, man.
Alright, it's not letting me go full screen with this for some reason. But yeah, so I went to, I'll make this easier for you. Yeah, so I went to Snorlax and then I went to types. I went to
You did
0.
You can't do .0. It's at 0 with the square brackets because it's an array.
Oh, okay. So it'd be like that.
And then no dot.
Dot
before.
array 0 or.
There we go. Because types is the array. You want the 0 index of that array.
It's still not loading anything after that, though.
All right, so let's take a look. So
Would I go into the slot?
Snorlax types at 0. Yeah, there's your problem right there. Slot is a number. you want type.
Okay, so I would just take slot out,
Yeah,
and then it would be type name.
looks like it to me.
Yep. Okay.
Woo!
Okay. Yeah. I guess I never really understood the whole numbers thing.
Yeah, so yeah,
I've never used that
like
before.
this is exactly like in like day 2 when we're just accessing parts of an array. Types as an array, we access that item on the array.
Oh,
and
the
then-
index. Okay.
Yeah, so if that returns an object, then we can just dot off of that. Yeah, you can't dot numbers and you can't dot variables. You have to use square brackets for that.
Okay. All right. Cool. Yeah, that was my only question. I just